Hello, everyone. Alfred Cromwell here. I'm going to be sharing with you a problem that literally the other day, this past week, created or provoked rather, sort of like a mathematical bloodbath. And we're still on the topic of exponents. I'm still not satisfied with how a lot of students are manipulating exponents. And so I figured I would make a video. I'll share with you all the problem. Now, if you're not interested in proofs, then what I decided to do, because I know a lot of you are not into proofs and you're new to mathematics, so it wouldn't be fair to start out with a proof. So in the beginning of the video, you're going to see me solve the problem, right? We're going to discuss. You'll see the problem. We'll discuss how to solve the problem, come to a conclusion, etc. And then those of you who are interested in actually rigorous mathematics, you can stay until the end, where we will have. I'll show you some fundamental proofs from. I'm actually going to share with you from my senior year in high school, my own notes. I've kept all my papers all throughout my life. I have an entire archive of everything I've done in life, academic wise. And so, what I will do is I will share with you what the proof that I did back in the day, and hopefully it serves you in some way. And we can come up with some fundamental laws about exponents. Also, at the end of the video, I will share with you the this what I discussed, how this book, Practical Algebra, how they discuss fractional exponents. So I hope this video is useful to you. I hope you find it interesting, and hopefully you've seen it. You're familiar with these. Now, prerequisite for the video: you need to know the laws of exponents, right? Like you need to know that when you multiply a base, the same base, you add the exponents, right? So I'm assuming that you have to have if you do not have those laws, then you need to watch my previous videos on the laws of exponents, right? Which I will link down below. But I'm assuming that you know how to manipulate expressions like, for example, 2 to the third times 2 squared is equal to 2 to the fifth. I also assume that you know that if you have a negative exponent, you could put a 1 over it and you get and you make it positive. So for example, a to the negative square can be rewritten as 1 over a squared. Again, if you don't know those laws, then you should not be watching this video because nothing is going to make sense. Math is all about prerequisites. You need to have a context in which to be able to manipulate certain things and understand certain things to be able to discuss it seriously. Anyway, here goes. All right, everyone, look on the board and see the problem that I gave students the other day. Before you solve it, ask yourself, or even if you solve it, ask yourself the question. I want you to manipulate this, and I want you to tell me. Please don't use a calculator, by the way. Makes no sense. Do it on paper. Is the expression, the exponential expression on the left side, equal to the exponential expression on the right side? Have a look at it. Pause the video, solve it. Let me know in the comments down below what you got. Right? No cheating. Let me know first, right? Be honest. If you're lying about your math skills, then you're not doing yourself any favors. Trust me. You got to be honest. Nothing wrong with not knowing something. All right. So, if hopefully by now you've paused the video and you've told me something. If we perform the operations here in each expression from left to right, we're going to see on the left side, negative 4 squared, if we follow the order of operations, negative 4 squared, there's a negative 4 in the parentheses. You have a negative base, but you're squaring it, so it actually becomes positive. So now you have 16 to the 1/2. And if you remember from our previous discussion in the other video, when you have a fraction or rational exponent, to be more precise, but some people call them fractional exponents, you can actually, the denominator becomes the index of your root. So when it's 2, it means the square root, right? So this means the square root of 16 can be rewritten, and the square root of 16 is indeed a perfect square. So our answer would be 4. Now notice what happens with the expression on the right. You now have negative 4, no parentheses, so it's 4 to the 1/2, which means the square root of 4, but you have a negative sign, a negation sign in front of it. So that these are not equivalent expressions. They are not. So this is called, by the way, this 4 here, the proper way of calling it, this is called the principal root. The principal root. I find a lot of textbooks these days, they don't label things correctly. And so students are often, they either don't label them correctly or don't label them at all. I've seen some books, there's a book series now called Illustrated Maths. What a joke. What a disservice to our young people. All it talks about is feelings. How do you feel about that? How do you feel about this? No proofs, nothing. Principle. They use that, by the way, in the Lost. I know for a fact that that's one of the books, one of the major books that they use in the Los Angeles Unified School District. No wonder California is doing so poorly academically. All you got to do is look at the SAT statistics to realize, among other indicators. So this is called the principal root. Now here, in the second example, or on the expression on the right, because we cannot have, we've said this many times before, we cannot have negative square roots in the realm of real numbers. I challenge you to contradict me on that one. So the way you rewrite it is, of course, we know that I squared, we have to use the set of imaginary numbers. We know that, you should know by now, that I squared is equal to -1. And therefore, your expression becomes 2i. Now you can write it as 2i, but it's not just 2i, right? There's an exponent of 2 outside the bracket, so it's 2i to the square. And since I squared is equal to -1, we have 2 times -1 squared, which gives you -4. All right? So hopefully that makes sense. But more precisely, this expression here, right? This is equal to -4. So what's going on here then? Well, 4 is not equal to -4. I hope you all agree with me on that. Right? 4 cannot be -4 because every number has an exclusive and unique identity. So that means that the result that you have here is not independent of the order of operations. When the base is a negative real number and the root is even, right? The solution, we have a dilemma here. So what is the solution? Actually, let me write that down because you need to know this. Let's write it down. Let's write down the law. We must restrict the base to only non-negative real numbers for even roots. When this is done, the order of operations does not affect the result. And based on this, right, we have a property of a number So what I'm going to share with you now, that was the kind of the proof part. This was something I wrote as a senior in high school, because I was very into this and I was always interested in why things are the way they are in math. And I wasn't satisfied with my gym teacher's explanations. So I'll give you the sort of what theorem I was coming from and how I proved it, how I broke it down. And hopefully this is going to be useful to you. So if we have, I don't like capitalized. I don't know why it does that. All right, have a look at this. If R and S are rational numbers and R is less than S and A is greater than 1, then A to the R has to be less than A to the S. This is an important property, important theorem here. Can we prove this? Well, there's several ways that you can prove things. I'm actually offering a course in mathematical proofs next semester, but for those of you who know what I'm talking about proofs, if you don't and you're still interested, stay along. So how can we prove this? So the way I broke it down back in the day, and I still use this in my classes, is you need to suppose, right, that we'll call n a whole number, right? Any whole number. Okay? Remember, a couple of properties here. If a is greater than 1, then a to the n has to be greater than 1. If a equals 1, then a to the n has to equal 1. Also 0, if it's less than a, and a is less than 1, then a to the n has to be less than 1. Now, with these properties, you can now prove and here's where we get it to, I'm just going to write it out because fed up with all the typing on the keyboard. A to the m over n rational exponents is going to be, very important, greater than 1 for m. And we have a restriction here. N is an element of the whole numbers. So the proof is indirect in a way, because let's say let's have a supposition. If a to the m over n would be equal to 1, then that means that a to the m would have to be equal to 1 to the n, which is equal to 1. Why? Isn't this a contradiction? Look at principle A. If a is greater than 1, then a to the n is greater than 1, right? Then, let's have, if it's less than 1, if a to the m over n is less than 1, then a to the m is less than 1 to the n, which is equal to 1. Why is that? Again, this is a contradiction here. This is contradicting principle A. So, since this expression, I'm going to circle it in red, since a to the m over n is not equal to 1 nor less than 1, right? Because otherwise you have a contradiction, then it has to be greater than 1. It must be greater than 1 according to our law here, right? Why is that? There's a principle in math that I expect that you've heard before. It's called the trichotomy principle. So this is by the trichotomy principle. Now the rest of the proof is easy, because if you let R and S, if they are any rational numbers, I hope you know what a rational number is, but and of course R has to be less than S, then S minus R is some positive real number. We could say m over n, for example. And why is that? Well, if we have a to the s minus r, then this is going to be equal to a to the m over n. And that's going to be greater than 1. So from here, you can come with a conclusion, right? It has to follow then that. What follows from here? See if you can come up with a conclusion then. I'll leave the rest of the proof up to you. But pretty much, I hope that this makes sense. Let's do another problem, by the way. So that was from my notes from senior year, and I hope it's useful to you. Hope it makes sense. Right? I'm going to leave you with a problem. We're going to do x to the negative 2 times x to the third, y to the negative 4, multiplied by 5y to the negative 3 to the negative 1/2. All right, I'm not going to give you the answer for this just yet. I want you to first tell me in the comment section, and I'll make a follow-up video with the answer for this. All right, but just let me know what you get. I want to, and tell me when you do it, tell me all the steps that you performed on this, and kind of justify why. All right, now this book here that I told you about, the Practical Algebra, I'm going to quote what they say because it's just really, really good. It says, we stated that square root of x squared needs to be clarified. And then the example they give is, it says, supposing we wish to find the value of negative 2, the square root of negative 2 squared. It says, we could write this, and I'm quoting directly from the book. We could write this with fractional exponents as negative 2 squared to the 1/2. And then it says, if you use this method, this becomes, right? So they break this one down, and then they say, okay, so that means negative 2 times negative 2 to the 1/2 Negative 2 times negative 2 is positive 4, so that's positive 4 to the 1 half, which equals 2, right? Fair enough. Then they say you have method 2, which is negative 2 negative 2 squared times 1 half, which is the same thing as saying, well, 2 times 1 half is 2 over 2, which is 1. And that gives you negative 2 to the 1, which is equal to negative 2. Now, you cannot have, again, two different answers to the same problem. So you have to agree, it says we must agree on a method that will yield a unique, that is one, answer. Accordingly, we established the following definition. I love the way they broke it down. I like their definition because for a student who is beginning with algebra, it's very clear cut. It says, definition, this is according to definition 7. The square root of x squared is equal to the absolute value of x. Or it says x squared to the 1 half is equal to the absolute value of x. And then it says, if we follow this definition, we will always achieve a unique answer. And then they give some example problems. It says, discover this for yourself. This is frame 15. It says, they also clarify, they also say, assume that the variables may be any real number. You see how they also talk about the restrictions here? A lot of mathematical textbooks do not, the ones that are used in many schools, they don't even go over that. They do not discuss that. So hopefully this was helpful to you. Let me know in the comments down below what you got for the problem that I gave you earlier. Where is it? This one right here. All right. And once you have it, once I see responses, I can do a follow-up video to see if you're right or wrong. Right. And again, do not use a calculator, please. And you got to use your skills here. The original, just to recap, the original problem was that I gave the class. Where was it? Somewhere. Oh, here it is. All right. This was what was creating a lot of confusion for students. A lot. And again, the reason why it's creating confusion is because you don't have these foundations. All right. So I hope you have a good Saturday. I hope it's productive. And I'll be uploading probably next week at some point. Thank you for watching. And if it was helpful to you, please subscribe. Please continue to bless me with your presence and with your wonderful comments. I always enjoy reading, even the negative comments. I get people who are, they just want to vent their anger somehow and they take it out on me. That's fine. When you become a public person, and I've been in public for a very long time, you got to be willing in a free society. You have to be willing to take some abuse. And that's just part of that's part of life. And I have a very thick skin because I grew up during a time when this whole thing of victims and all this, you had to stand up for yourself. Believe me, I can stand up for myself. I'm a big boy now, and you can leave your comments. If you're angry or whatever, if it helps you vent, I'm glad I'm contributing to your your mental health. Thank you.